Let's take a look at the process of solving this polynomial equation. The first thing I want to do solving a polynomial equation is look for a greatest common factor. If there's not a greatest common factor, that's okay, but here I can see all the coefficients are divisible by 2. So if I factor out a 2, I'm left with x to the fourth minus 4x cubed minus 8x squared plus 32x minus 21 equals 0. And then dividing by 2, that 2 is really not going to do anything in terms of what the solutions to the original equation are. Because if I divide 0 by 2, I still get 0, and this kind of goes away, so we end up with a simpler equation, x to the fourth minus 4x cubed minus 8x squared plus 32x minus 21 equals 0. So we can look at this, and our search for solutions will be simpler because now the coefficients are all, half the size that they were at the beginning. The rational root theorem says the solutions that are rational numbers have to be of the form p over q, where p is a factor of the constant term and q is a factor of the lead coefficient. Since the lead coefficient is just 1, the only factor there is 1. 21 has factors of 1, 3, 7, and 21. So the possible rational solutions, I need to include positive and negative values. I get plus or minus 1, plus or minus 3, plus or minus 7, or plus or minus 21. So that limits, I have 8 possibilities, which is not a small number, but it limits what I need to look at. We could possibly limit things more if we look at Descartes' rule of signs. I can see for positive solutions, the sign changes from positive to negative, and then negative to positive, and positive to negative. So that's 1 change, 2, and 3. So there could be either 3 or 1 positive solutions. For possible negative solutions, I would change the sign of odd degree terms. So this would become positive, but that would stay negative, and this would become negative. So then we would have, highlighting this with a separate color, let me see. So the 4 wouldn't change, so that would be positive. This would, it would stay positive. This wouldn't change, it would be negative. And then this would change, and this would stay the same. Right, so the constant term is an even term. The degree of the constant term is even, I should say. So there's only one change for the negative coefficients. So there could be possibly positive solutions, and there could possibly be negative solutions. And in fact, this suggests that there is at least one positive solution and at least one negative solution. So let me start with positive numbers, I guess. Maybe that might be easier to work with. And we can use synthetic division to check for possible solutions. So if I plug in 1 and look at the coefficients, 1, negative 4, negative 8, 32, and negative 21, I can divide this. Essentially, we're dividing by x minus 1. Bring down the 1 times 1 and add. Times 1, I get negative 3. Adding is negative 11. Negative 11, adding, I get 21. But then multiplying by 21, I get 21. And then adding, I get 0. So because we got a remainder of 0, 1 turns out to be a solution, and I can think of this equation as a simpler one, where one factor is x minus 1, and the remaining factor comes from the coefficients of the quotient, x cubed minus 3x squared minus 11x plus 21. So the first factor gives us a solution of 1. The second factor, well, maybe it will give us more solutions. Essentially we have the same possible solutions, except now we know we've encountered one positive solution, so now maybe let's look at negative solutions to see if we can find one. So I'll start with negative 1. The coefficients that I want to use now are 1, negative 3, negative 11, and 21. And I can divide. I get 1 now times negative 1 is negative 1, negative 4. Times negative 1 is 4. I get negative 7, and times negative 1 is 7. So adding those I get 28, so -1 is not a solution. So we need to look elsewhere. Well, another option would be the next positive or negative number. So let's see if -3 is a solution. Again, I want to use the coefficients of the quotient from my first problem. We're just kind of looking for solutions that make this factor equal to 0. If I bring down a 1, multiply by -3, I get -3. Add, I get -6. Times -3 is 18, positive 18. And if I add those, I get positive 7. Times -3, I get -21. And adding those, I get 0. So it turns out we didn't have to look too much further. -3 is also a solution. And so now my equation can actually be written as x minus 1 times x plus 3, right? Because essentially putting a -3 there means I was dividing by x plus 3. So that's another factor. And then the remaining is x squared minus 6x plus 7, right, from the coefficients of the quotient. So 1 is a solution from this factor, -3 is a solution from that factor. If there are additional solutions, they would be values that make this third factor equal to 0. So we could think about factoring this. Try to find two numbers that multiply to equal positive 7 and add to equal -6. To multiply to equal positive 7, they would have to have the same sign. But the only factors would be 7 and 1, and they aren't going to, if they have the same sign, they aren't going to add to -6. So this doesn't factor. We could use completing the square to try to figure this out. Essentially, I want to solve the equation x squared minus 6x plus 7 equals 0. If this was a 9, it would be a perfect square trinomial, right? Dividing the 6 in half and squaring it gives me 9. So to turn a 7 into 9, I need to add by 2. So that means I need to add 2 on the other side. So I end up with x squared minus 6x plus 9 equals 2, which is the same as x minus 3 squared equals 2. So x minus 3 equals plus or minus the square root of 2. And two other solutions, and the final two solutions, would be x equals positive 3, adding 3 to the other side, plus or minus the square root of 2. If you don't like completing the square, I don't know why you wouldn't, but if you don't like completing the square, you could use the quadratic formula. Since it doesn't factor, that would be another option. So we end up with a solution set that includes 4 values, which makes sense because we have a degree 4 equation, a degree 4 polynomial. One solution is -3, another solution is positive 1, and then we have 3 plus the square root of 2, and 3 minus the square root of 2. And if you think about what the square root of 2 represents, it's the number that if I square it, I get 2. That number as a decimal is like 1.4 something, 1.414, and so on. And so it's smaller than 3, so subtracting it, this is going to be a positive solution. This is also positive, of course, because I'm adding the 2 values, and then positive. So I have 3 positive solutions and 1 negative solution. And so that agrees with what we would expect from Descartes' rule of signs. We end up with 3 positives and 1 negative. I hope you enjoyed the video. Thanks for watching.